Hi everyone, in this video we're going to look at how you actually build the equation of your line, which I know you know. We've gone over it in class and you have some notes and resources on how to find a C value, how to find the A value, how to find the B value, but this can just be used as a resource. So what you want to do is find your data on your Desmos, so make sure you're logged into Desmos and hopefully you saved your data. And I'm going to pretend that I have not built either of my equations. So just like you, I have my data stored on Desmos. I have my x-axis labeled, my y-axis labeled. And then we did this in class, but let's just remember. So on your final project, part of the project is finding the equation of a good fit. It's kind of like a pair of jeans. It's never going to be perfect, but a good fit for an equation that goes through your data. So on Vlad's, we took some notes on this, especially in this area, and this is a reminder of what we did in class. So a building block for our exponential unit, we got our multiplying ratio here, we got our robotic dogs, the flat part of your graph here, and then we have kind of the starting value of our family here. Remember that A and C together form the y-intercept. So you can go actually into your own project template and you can actually follow along with us here for your project. You're going to enter your information into this part of your paper. And so the first thing that I did was I figured out what my robotic dog population was, what my C value was. And we see that by the flat part of our graph. So if I blur my eyes and kind of maybe set a ruler to this and kind of estimate where it's going to flatten out, it looks like mine is somewhere around 20 or 21. And in class, we decided to use 21, C equals 21. And that is our level off height, or also known as our asymptote, our horizontal asymptote. The next thing we did was we went into our graph and we tried to figure out, okay, if I followed and blurred my eyes again and followed this up, where would approximately I hit my y-intercept? And so if I follow the pattern, it looks like it's going to be somewhere in this region. And we decided to use 68 as a y-intercept. So going back to here, using our estimated y-intercept of 0 as our x and 68 as our y, we can obtain our a value. So you always go back to your building block, Lx equals a times b to the power of x plus c. This is actually y equals. My project is listeners in terms of rank, so that's why I label it L of x, but you might have a different one. So y equals 68 becomes our y value, 0 becomes our x value, and we can see that b to the power of 0 is just 1, so I end up getting, if I subtract 21 on both sides, 47 equals a times 1, and therefore 47 equals a. So now I have my a value and I have my c value. The last part, the most challenging part, is finding a good estimate for your b value. So we can just do an example, and we're going to share with our audience an example, but really we need to calculate a b value for all of our data points and take an average. So I used a pretty easy point from my data collection. So I found an easy point to use. A lot of them are decimals, but this one is an x value of 5 and a y value of 32. It doesn't really matter which one you use. You don't want to use an outlier, but try to find an easier data point to use. And so 5 is my x value that gets put into my building block. 32 is my y value, which gets put into my building block. And then I use PEMDAS backwards to solve for b. So I subtracted 21 on both sides, then divided by 47, and then took care of our exponent by taking the fifth root on my calculator of 11 over 47. Remember that your X root button is under your math button on your TI-84 calculator. You could also calculate it on Desmos. It would be under this keyboard here, I think under function somewhere. Yeah, there we go. You could also do that on Desmos. Once you show an example to your audience, dear audience, here's an example of how you calculated your b value, you could do it by hand for the rest of your data points. But that would be working way too hard. So a friendly reminder that as an assignment in the past, I taught you how to find a b value in Google Spreadsheets. And so you might want to go back to that YouTube video here working with our example QUOC data collection to remind yourself how to get a b value in Google Spreadsheets, and then you can actually do that within your spreadsheet. And my average b value when I did my algorithm in Google Spreadsheets was 0.750. And so now I have the equation of my line, the equation of my model. Let's get back to that example. And I know that my average V value is 0.750. Therefore, I have my final equation here. The most exciting part is seeing if it fits your data. And you might need a little adjustment, and that's okay. You can talk about it in your paper. But if I go into Desmos and type that in, I'm going to want to call it L of X. Okay, equals, and I want to show that it fits my data very, very well. The last thing that I want to show you how to do is you can have your final equation, which I personally think is a great fit for my data. But like a pair of jeans, you also want to see what Desmos has for a fit for your line. The way that you do that is a regression model on Desmos. You do y1 is approximately equal to. You're telling, hey Desmos, please model this for me. And then we enter our exponential building block, a times b to the power of x plus c. My data is in y1 and x1, so I tell Desmos to use list y1 and list x1 to form that. And it says it's a pretty good model, 0.98. A perfect model that fits the data perfectly would be 1.0 here. You can kind of look at both and decide which one, like a pair of jeans, there's not a right answer, which one fits better. I personally liked my model better. So even though I screenshot that into my paper as a comparison, I'm going to end up using L of X to analyze for the rest of my paper. So there's both of my model fits. I screenshotted that in, and then using the model I decided, my L of X model, I was able to go on and analyze my personal second question. You might have a different second research question. Like you might, in this part, do a comparison and do your other model. Or maybe you don't have a second question at all, and that's okay too. So you have that next math process there. So the big goal for this video and for today is to really work on building an equation from the beginning, a times b to the power of x plus c, that fits your data well.